Hi everybody, so a second video for my WiHoWi and Wire Gcode Standard solutions. We will start by the WiHoWi screen here where the wing is already ready to be exported as a G-code. I have set the wing length at 600 millimeters and chosen a feed rate which is quite high, 400 millimeters per minute, in order to have something fast enough on the screen. I export the G code. So this one, I record it. And now we can jump to the streamer, which is here. First thing that we have to do is either to scan and to connect. We will do it. So I will connect to the COM10 of the board. Where is my fluency board? The connection is immediate. So this is this is fluency which is speaking. We are trying to connect. The connection is done, and we are somewhere into the last position where I left my machine. We will open the G-code file. So easy. And here is the result. The wire currently is here. That is far from the origin. The origin is located on this side of the stock and on the table that is at the bottom of the stock, exactly this edge. We can move the wire using a coordinate motion from left and right. So here I push on the button and the wire is moving to the right. We can change the speed and have something faster. And the wire will move faster. I can move up. I can move only the left X direction, the right X direction, etc., etc. And you can also click on this go to zero button and the wire will move to its origin, that is exactly on this edge. What you will do usually is to set the zero position of the wire when it will be totally square on the table, and then you will align the stock touching this edge. You can zoom and you can see that the G-code file has been read, and some of the comments here, the wire length, is used to make this drawing, which is very useful. And you have also the position of the stock, which is read from the WiHoWi application using the headers of the G-code. We are ready to cut this wing. What we will do is simply click on the Run button, and the wire will go to the entry point, start the heater here, and begin to move to the entry of the wing, which is on this point here and somewhere on this point on the foam. When we are at the entry point, the motion will start. Here it is. So the two profiles are totally synchronized, and we will progressively reach the hole, which is here, there, and there at the same time, and cut the hole in a very few seconds. So here is the entry. Up. It is cutting the hole. Then the wire will make the loop at the leading edge, reach this hole here, there, and cut it. Finally, we will make a synchronized motion to the edge of the wing. It will arrive at the same position at the same moment. So here it is almost. Okay, and now we will exit the foam and stop the heater in a few seconds also. Okay, so it's an accelerated motion, but the motion is really done by the board. It's not a simulation. So we are here, and what you may want to do is to cut the foam. That is to only keep the shell here at this position, for example. And for this, you have some special moves here which are ready to be used. You can go, for example, to the stock top. I will do it. The G code is immediately positioned into the console and you can send it. And the wire is going to the top of the stock. You can go to the exit point, but you can also use this to make some very nice shell cutting. I will use the motion here. And what I will do is to make a go to the top, followed by a go to the entry with margins. So we will be somewhere here, sorry, here. And then we can cut by another move to the bottom. And all this being done after starting the heater. Here it is. I click on the send button and look at the wire. It's climbing on this edge. When reaching the edge, the wire is going to the start position. That is exactly this position, and now going here and cutting this side of the foam. You stop the heater and you can remove this triangle. It's not easy to see the motion, but I will redo it manually. That is, I will move the, yeah, it is, I move up, sorry, it's too fast. I move the wire manually at a speed of 100, which is much slower. And you can see that the wire is exactly at the entry into the foam that I have specified. So here and there, and that I have cut a vertical position into the shells. You have a lot of special moves that you can use to go to the exit. You go to the exit plus the margin and so on. Try all this. It is easy. Something which is also important is that if we go back to the WiHoWi, you have the possibility to enter kerf. So I will put again 0 here and look at what is doing the root. If I put 0, the root is shrinking and going back to the original position. So the kerf is exactly the diameter of the wire, which will follow the profile, plus what will be eaten by the wire into the foam. It's important to calibrate the kerf for the root, but also for the tip, because this will be cut at a slower speed than the root, and so will eat more foam. So what you can do is to set the kerf to 0 and to use this special menu, which is here, to calibrate the kerf. This will output a G-code file, which is here, calibration 50 by 10. And you will see what is this G-code. So go back to the streamer, open the G-code, that is the calibration. And it is a very simple G-code. It is cutting simply a rectangle whose height is exactly 10 millimeters and the length at the root is 50 millimeters, and at the tip it is proportional to the wing that you are cutting. So that if you cut this shape here, you will get a tapered rectangular shape, which will be exactly 10 millimeters here and should be also 10 millimeters here. But due to the fact that you have chosen a speed here and something proportional there, you will have something smaller here and even smaller there. If you measure this dimension and this one, you will get the kerf. So let's try to cut it. At what speed? 400. So we are starting here. We are reaching the entry point, making the move, cutting the shape here, and going down and finishing the move. If you extract the core shell here, you have this small wing, which is not a wing, where you can measure exactly the dimensions. Go back here to the WiHoWi, enter the value. Let's say that we have read 1.4 millimeters there and 2 millimeters on this one, and you get the curve. Export the G-code, and that's it. You have something which is calibrated. So it's very easy to do and very efficient. What else on the WiHoWi? In fact, not a lot, but something which is important also. I will open again the wing and start to cut it. So I push on the run button. It's reaching the entry point and it will perform the cut. You have this pause stop button, which is very useful in case of emergency when you are cutting. You can push the button. The first short click will pause the cut, so it's not a good idea because while paused, the heater is still on, so it will heat the foam. But you can resume the cut. Stop again, resume, stop again. If you are in a very critical situation, you can long click on the button and Fluidency will receive an alarm. It is an abort cycle. That is, we want to reset everything and stop the motion. You are into an alarm condition. You have to clear the alarm. Click again on the pause stop button, and we have received here an unlock message sent to the board to recover the motion. And now you can move again, exit from the foam, go to the zero, and recover your machine. Something also which is interesting is that when you have made a G-code file for cutting left wing, this is the left wing, and you want to cut the same wing for the other side of the plane, there is no need to redesign the wing. Simply swap the motors here, and this can be done here on the menu. Open a G-code and swap the motors. So look at what will occur. We will swap the left and right axis right now. So now the root is on the right motor and the tip is on the left one. As your foam stock is centered between the two towers, the motion will be the same and you get the same wing but for the other side of the fuselage. And that's it. You can override the speed here. I do not recommend it, but you can. You can also override the hot wire temperature here. And this is probably more useful because if you discover that the wire is a little too hot or a little too not enough, then you can override the value here. And that's it. For the jogging, if you simple click on a button, it will perform the motion, which is here with a fixed distance. So here, I click, it moves 10 millimeters on both motors. Click again, 10 more millimeters. If I want to recover to the 0, you can put 20 millimeters there and click. And something which is extremely useful is that if you long press on a button, then the jogging will be permanent. So here I move, it moves. Something also which is useful, maybe a bit more technical, if you want to cut from this point at a certain angle that is hitting the foam, you can do it here. And this is useful to cut a diagonal into the wing. So now if I push on this button, the motion will be done into both directions, X and Y. Go back down and the motion will be done at the angle that we have chosen. Remember to put 0 to recover for vertical motion. And that's it for WiHoWi. So it's very, very simple application. Nothing special. It is a streamer. Remember that this streamer is only capable today to run with a fluidency board, but fluidency is the reference, I mean. And of course, it can work with other G-code files produced by other software. You are not limited to the WiHoWi G-code, but with WiHoWing, you have this all these headers where the special motion here, special moves are extracted. It will not be the same with other G-code files. You have also something which is specific to the foam cutter. It is the dimension of the wire and also the dimension of the stock. And this is the reason why WiHoWi and hoWiGS should work together to get the most efficient way for you to cut your wings. So happy foam cutting. Goodbye.